Greetings everyone, this is Mr. Keppel. This is PHYZR number 3, Math with Tens. This is from the Prelims chapter, it's page number 4. The purpose of this PHYZR is to teach you how to multiply and divide by the number 10. This is probably something you already know, but you'd be surprised with how many students I see in physics at Fremont who don't know how to multiply and divide by 10. This is the reason why I've banned calculators from my class, and it's because I saw way too many students trying to use their calculators to multiply and divide by 10 when it's something you could easily do in your head. So that's what we're going to do today. We're going to learn how to multiply and divide by 10. I'm going to teach you the fundamental concepts underlying this and eventually practice and hopefully get to the point where you can multiply any number by 10 or divide any number by 10 very simply and easily in your head. In our number system, we only have 10 symbols to represent an infinite amount of numbers. Any number you can think of, no matter how big or how small, has to be written using just these 10 symbols. And this is going to cause some issues, but it's also going to be the reason why it's so simple to multiply and divide by 10. Because 10 is the number of symbols that we have. The first issue is with counting. If we start counting with our symbols, look what happens. Eventually, we run out of symbols. If the symbols only go up to 9, how can we write numbers greater than 9? It's a discussion question, so think about it. Having only 10 symbols in our number system forces us to get creative when we try to write numbers that are outside the range of those basic symbols. And for this reason, we invented the numbers place. So the solution to counting above 9 is that you basically reset the symbols back to 0 and then start counting in a new numbers place. And then we get the number 10. Now notice, this is actually not one symbol, this is two symbols. And what this is, it's a 1 and a 0. So think of it as 1, 0, not as 10, because here's the idea. In the tens place, we have the number 1. And what this shows us is that we've run out of symbols one time. So in the ones place, we have the number 0. So really what this is showing us is it's saying it's the number 10, 1, 0, because we've run out of symbols once. To count numbers past 9, we add a new numbers place and we start over from 0. If we were to continue counting, for instance, go up to 11, 12, 13, realize we're only changing in the ones place because we reset the symbols. We have enough symbols now to count. But then when we hit 19, we've run out of symbols again. We're at the 9. We don't have a number symbol to go above this. So we increase the value in the tens place to 2 and reset the ones place back to 0. So notice this number 20 says that we've reset the symbols 2 times. We've run out of symbols twice. Another problem that arises is how do you count between sequential numbers? So if we only have 10 symbols, we don't have symbols for the in-betweeners, for the numbers that come in between two other values. So as an example, what number is this? This number is halfway between the numbers 1 and 2. The discussion question is, how do we write values that are between two sequential numbers? You're having trouble understanding this question? Let me explain a little bit further. So see this number that I'm pointing at, it's not the number 1, nor is it the number 2, but those are the only symbols that we have. We only have 10 symbols. So how do we reference this number that's halfway between 1 and 2? Once again, the solution to this problem will be to add another numbers place. But first, what we're going to do is break up the spacing, the gap between these numbers, with 10 smaller spacings, 10 smaller gaps. Now, why would we pick 10? That's right, it's because we have 10 symbols. So now we'll add another's place. We'll call this the tenths place, and it goes to the right of the ones place. And what we do is we put a decimal place after the ones place to show that these parts that come past the ones place, this tenths place, are fractional pieces of the number. And so now see, we have this gap between the 1 and the 2, and now we have 10 smaller gaps between it. So all we have to do is just count how many gaps we go. So one gap over is 1.1, another one's 1.2, and we'll keep going until we reach the number in question, and it turns out it's 1.5. So the number 1.5 represents a number that's halfway between 1 and 2. Numbers between two sequential numbers are written with decimal places. Again, this is a numbers place concept. So remember, like I said in the previous slide, numbers places were invented to allow us to count an infinite amount of numbers using only 10 symbols. Here's something you probably already know how to do. What is 2 times 10? Most teachers, when they're teaching their students this, especially in middle school, they'll simply teach students to just add a 0. When you multiply times 10, you just add a 0 onto the number. This rule works. It doesn't work all the time, but it generally works. It's simple. It's an easy way to understand it, but I don't want you guys to think about things that simply. I want you to really understand what's going on. So we'll start by placing a number 2 in the ones place. This is our starting position for the number 2. Now the times 10 tells us that the number 2 is going to get 10 times larger. So how do we do that? So I'll direct your attention down here where the number 2 is in the ones place. If we want to make the 2 10 times larger, then what we do is we move it over one space to the tens place. Then that's why you add a 0. It's not because you just add a 0. It's because when you move it over, you have to put a 0 there as a placeholder for the ones place that has been moved over to the tens place. You have to use a 0 as a placeholder. My question is, why does this work? Why are we allowed to just move the 2 over one numbers place? Think about it. It's important to realize that this doesn't work for times 4 or times 9 or times 15. This only works for times 10. So what is it about the number 10 that makes it so simple that we can just move the number over one space? Why does this work? Well, hopefully if you've been paying attention, you'll remember something special about the number 10. That's the number of symbols we have. Since there are only 10 number symbols, multiplying by 10 makes a number bigger by one space. We've run out of symbols. The number of symbols has reset, so you could just move it over to the left one space. Realize that multiplying by 10 can never change the actual number. In this case, the number 2 would never become a number 5. And that's because you're just multiplying times 10. You can see when you have 2 times 10, there's a 1 in the number. And we all know that multiplying times 1 doesn't change the number. So all that happens when you multiply times 10 is you are simply moving it to another numbers place. And it works because that's how many symbols we have. When you multiply times 10, we've reset the symbols. So the real way to think about multiply times 10 is to not think it gets 10 times larger, but rather to think it gets one space larger. We've moved it one space to make this number larger. Here's a problem where the basic add a zero rule completely fails. If we're going to do 4.8 times 10, if you were to just add a zero to this, you would still have the same number, 4.8. That rule doesn't work. The add a zero rule breaks when you have a decimal value. But the get one space larger does not fail. So if we have 4.8 times 10, we need to make this one space larger. So we're going to take our 4.8 and we're going to move it over one space. And now you see that this is no longer the number 4.8, it's the number 48. And 48 is one space larger than 4.8. You can see that it now comes out to the tens place. It's one space larger. We can also use a similar idea for dividing by 10. So if we have 7 divided by 10, in this case, the divide by 10 tells us to get one space smaller. And that's because we're doing the inverse operation to multiplication. We're doing division. And division does the opposite of what multiplication does. So if multiplying by 10 makes it larger, dividing by 10 is going to make it smaller. So number 7 will get one space smaller. So what do we need to do to this number 7 to make it one space smaller? Well, if we're on the ones place, what's one space smaller than ones would be tenths. So we simply need to move the 7 over. And now you can see that the number we have is 0.7. We've added the 0 in the ones place as a placeholder. Some people don't actually write zeros in front of their decimal points. I just make it a habit to always do it. I just think it looks nicer. This rule also works with decimal points. If we have the number 8.3 and we divide it by 10, the number will get one space smaller. And so one space smaller than 8.3, we're going to move it over. It's 0.83. The number is one space smaller. As a summary of the rules, we can say that multiplying a number by 10 will always make it one space bigger. So that means that we'll move it to the left. This is where the add a zero comes from, because every time that you move a number to the left, you end up leaving a hole behind, and then you have to add a zero to that hole. So multiplying a number by 10 makes it one space bigger. And for division, dividing a number by 10 makes it one space smaller. And that means moving it to the right to make it smaller. These rules will always work for every number you can encounter, whether it's a decimal or a whole number, and this is the way you need to think about multiplying and dividing by 10. I'd like you to solve each of these problems on your paper. Please do not use a calculator to solve these problems. If you use a calculator for these multiply and divide by 10 problems, it's defeating the entire purpose of this lesson. You need to solve these problems using the rules we just went over of getting one space larger or getting one space smaller. I'll give you about 30 seconds to finish these up. Let's go over the answers. 5 times 10 is telling us to make the number 5 one space larger, which will give us 50. 0.4 times 10 also says to get one space larger. Right now you can see that the number 4 is in the tenths place. The tenths place. So one space larger than that would move us to the ones place, which will make the answer to this 4. 36 divided by 10. Right now our number is in the tens place, and since we're dividing by 10, we're going to get smaller. So the number 3, which was in the tens place, will move to be in the ones place, which will give us 3.6. We have the number 0.04 times 10. The number 4 is in the hundredths place, and multiplying times 10 will make it larger, so the number 4 will move to the tenths place. So it'll be 0.4. 2 divided by 10, 2 is in the ones place. Dividing by 10 will make it one space smaller. It needs to be to the tenths place. That'll give us 0.2. 0.7 divided by 10. Number starts off in the tenths place. We're going to get smaller, so it's going to move to the hundredths place. It's going to be 0.07. 15 times 10. Our number, let's look at the 1, is in the tenths place. Times 10 makes it larger. We're going to move it to the hundredths place. So the number will be 150. 0.4 divided by 10. The number 4 is in the tenths place. Dividing by 10 makes it smaller. It's going to move to the hundredths place. It's going to be 0.04. If you didn't understand any of these, make sure you go back and correct your mistakes if you got any of them wrong. Learn from your mistakes. You may have also, if you have prior knowledge multiplying and dividing by 10, there's another rule that a lot of teachers actually teach, and that's moving the decimal place. That works perfectly fine. You can see for this one, 0.4 times 10, you can use the move the decimal place rule. And the rule goes something like this. If you're multiplying by 10, you need to move the decimal one space to make it larger. That would mean we'd move it to the right. You can see now that's 4 point, which is the number 4. For here, there's always an invisible, on the next one down, 36 divided by 10, there's always an invisible decimal point after every number. So where the red circle is, that's the decimal point. If we're going to divide by 10, we would move the decimal place one space to make it smaller, 3.6. This is the same rule using the numbers places or moving the decimal place. It's the same exact rule. Let's move on. So now we'll make it a little bit trickier, but realize that this isn't any different than what we've already been doing. What is 7 times 10 to the third power? You have to understand that to the third power means that this is 10 times 10 times 10, or 10 multiplied by itself 3 times. That's what the exponent is showing us. So essentially what we're doing here is we're taking the number 7 and we're multiplying it times 10 3 times. If it was just 1 times, if it was just 7 times 10 one time, then we would just move the 7 one space larger. But since it's multiplied by 10 3 times, that means we're going to get 3 spaces bigger. Each times 10 makes this one space bigger. So if we place our number 7 in the ones place and make it 3 spaces larger, then you can see we have the number 7,000. If we instead multiply by a negative power of 10, our number 7 will get 3 spaces smaller. The negative is showing us that it's getting smaller. In fact, a negative exponent is actually division. 10 to the negative 3 is actually 1 over 10 to the positive 3. So if number 7 gets 3 spaces smaller, it'll move to the thousandths spot. Now this number is 0.007, or you could call it 7 thousandths. Here's some power of 10s to practice on your paper. Remember, don't use a calculator. Using a calculator is cheating. Practice solving these problems. Give you about 30 seconds to do so. Seven times 10 to the second power. Notice the 7 is in the ones place. Come over to the ones place. Multiplying times 10 to the second power means we need to get larger by 2 spaces. So starting in the ones place, we'll move 2 spaces larger, and now the 7 is in the hundredths place. So the answer to 7 times 10 to the second power is 700. For the next problem, The number 0.2 is in the tens place, and times 10 to the third power means we need to get 3 spaces larger. So starting from the tens place, we'll move 3 spaces, 1, 2, 3. Now we're in the hundredths place, which means the answer is 200. For 70 times 10 to the negative 4, it's 0.007. So notice what we did. We started with the 7 in the tens place, and we got 4 spaces smaller. 7 in the tens place, 1, 2, 3, 4 places smaller. We're in the thousandths space. You can also use the decimal point rule of moving the decimal. The decimal starts off here. We're going to move it 4 spaces smaller. It's going to go 1, 2, 3, 4. And you see, this is why I don't really like the decimal rule, is because you kind of run out of space, and then you got to keep track of the zeros, and it just kind of gets messy. I much prefer using the numbers places method. I think it's easier, and it's sometimes often faster, and you can do it in your head. The next problem, 2 times 10 to the negative 2, we'll start in the ones place, and we'll get it 2 spaces smaller since it's a negative 2. In the ones place, 2 spaces smaller, 1, 2. We're in the hundredths place, it's 0.02. 0.1 times 10 to the negative 3, starting in the tenths place, our number will get 3 places smaller, 1, 2, 3. So now we'll be in the 10,000th space, and then the answer will be 0.0001. Our last problem down here is 0.82. We'll start in the tens place for the 8 in the tens place, and we're going to get 4 spaces larger. 1, 2, 3, 4. Now the 4 will be in the thousandths place. So know the answer is going to be 8,200. Again, if you made any mistakes on your first run through these problems, make sure you go back and correct the mistakes. And instead of just correcting them, actually ask yourself, why did I get it wrong? What was my flawed reasoning that led me to get the wrong answer? And make sure that you understand how to get the correct answer. To conclude today's PHYZR, tell me which of these numbers is the largest. Before I tell you the answer, I'd like to tell you a few flawed answers that use flawed reasoning. The first is this one down here. A lot of people will pick this for being the largest number. And the reason why is because they have 5,000. And if you don't understand what times 10 is, most people just ignore it because they don't understand what it means. And if you just look at the number in front, then clearly, obviously, this one's the largest. 5,000? These other numbers don't come anywhere near reaching 5,000. That's a flawed reasoning because the times 10 is going to change that number in front. Another flawed reasoning is to pick this number up here, 0.05 times 10 to the 6th. And people will pick that one because they say, whoa, it has the highest power of 10. It's 10 to the 6th power. The one with the highest power is the largest number. And that reasoning is also flawed. In order to say which number is the largest, we need to resort these numbers. We need to shuffle them. We need to show them from order of highest power of 10 to lowest power of 10. And if you do this, a pattern emerges. Now look at the numbers in front. You should see a pattern. I'm going to leave this up here for a moment to make sure that you really see the pattern. Again, I'll ask you, which number is the largest? If you still can't see which number is largest, then let's go ahead and take each of these numbers that are written out as a power of 10, and we'll write them as the actual value that it represents. So 0.05 times 10 to the 6th, we're going to get 6 spaces larger. 1, 2, 3, 4, 5, 6. So you can see that the number 0.05 times 10 to the 6th power is the number 50,000. We'll do the same for all the remaining numbers. 0.5 needs to get 5 spaces larger. 5 needs to get 4 spaces larger. Remember, there's always an invisible decimal point after every number. The number 50 needs to get 3 spaces larger. Invisible decimal point. 500 needs to get 2 spaces larger. Invisible decimal point. And the number 5,000 needs to get 1 space larger. My wife says this is a trick question, but I don't think it's a trick question. If you actually understand powers of 10, you should have known that all of these numbers are the same number. They are all equal to 50,000. So which numbers are the largest? None of them. They're all the same value. As a final thought, which of these values up here, all these values, is in scientific notation? Now you may have already taken the scientific notation lesson before watching this, and remember we say that the value in front of the times 10 has to be between 1 and 10. It has to be greater than or equal to 1 and less than 10. So the one that's in scientific notation is this one in the middle, 5 times 10 to the 4th power. And so notice that if we make this 5 1 space larger, then the power of 10 gets 1 space smaller in order for it to stay the same number. This is a very important idea to recognize and to realize, because this is how you can easily quickly take numbers that are written out as powers of 10 and change them into scientific notation. So for example, if you had 0.5 times 10 to the 5th power, realize that all you need to do is take the number in front and make it 1 space larger, which would then require you taking the exponent 5, making it 1 space smaller, so then it's written in scientific notation. That's it for today's PHYZR. I hope you guys had fun. I hope you learned something, and I'll see you in class.